What's out there that we can't see? The truth is, our universe is teeming with mysteries, many of which are far beyond human comprehension. Now let's consider the concept of visible matter. This is the stuff we can see, touch, and interact with. It's the stars, the planets, the galaxies, even you and me. But guess what? All of this visible matter, everything that we can observe with our eyes and sophisticated telescopes, makes up only about 5% of the universe. Yes, you heard right, just 5%. So what's the remaining 95%, you might ask? Well, that's where things start to get really interesting. Let's introduce you to a concept that might seem straight out of a science fiction movie: dark matter. This is something we can't see or touch, yet it's believed to make up about 27% of the universe. That's over 5 times more than all the visible matter put together. Now, you might be wondering, how can something we can't even see be so prevalent? And that's the beauty of it. Dark matter, despite its elusive nature, is believed to play a crucial role in shaping the universe. It's the hidden hand, the unseen force, the silent influencer that holds galaxies together and dictates the movements of stars and planets. Imagine that. Something we can't see or touch, yet its influence is so profound, its presence so dominant. It's like a phantom puppet master pulling the strings of the universe from behind a cosmic curtain. So what exactly is this mysterious dark matter? Imagine being in a pitch-black room. You can't see anything, but you know there's something out there. That's dark matter. Dark matter is like the invisible puppeteer of the universe. It's a mysterious, unseen force that makes up about 85% of the matter in the cosmos. Yet, despite its prevalence, it's something that we can't see or touch. It's like the wind. You can't see it, but you can feel it and see its effects. Think of a windy day. You step out and your hair is whipped about, your clothes flutter in the gusts, and leaves rustle in the trees. You can't see the wind, but you know it's there because of the way it interacts with the world around you. Similarly, dark matter can't be seen directly, but its gravitational effects can be observed. Imagine you're looking at a galaxy far, far away. The stars on the outer edges are moving at speeds that should, by all accounts, send them flying off into the cosmos. But they don't. They continue to orbit the galaxy as if something is holding them in place. That something is what scientists believe to be dark matter. Dark matter, then, is a bit like the invisible strings that hold the universe together. It's the glue that keeps galaxies intact, the unseen hands that shape the cosmos. Without it, galaxies would fall apart and the universe as we know it would look very different. But here's the catch. Dark matter doesn't interact with light or any other form of electromagnetic radiation, making it incredibly hard to detect. It's like trying to see the wind. You can't. You can only see its effects on the things it touches. So, we're left with a paradox. We live in a universe where the majority of matter is something we can't directly observe. We can only infer its existence from the gravitational pull it exerts on visible matter, the stars, galaxies, and clusters that make up the known universe. But how can we be sure dark matter exists if we can't see it? Science is all about evidence, and even though we can't see dark matter, we can see its effects. Let's delve into the 3 main pieces of evidence for dark matter: galaxy rotation curves, gravitational lensing, and the cosmic microwave background. Each of these phenomena provides a tantalizing glimpse into the influence of something we can't see, but which seems to permeate the universe. First up, galaxy rotation curves. We can observe stars in galaxies rotating around their centers, much like how planets orbit the sun. But here's the catch. The stars at the edges of galaxies are moving way faster than they should be, defying the laws of gravity we know. This suggests that there's some unseen mass, some dark matter, that's pulling on these stars, making them move faster. Next, we have gravitational lensing. You know how a lens can bend light? Well, gravity can do the same thing. Massive objects like stars and galaxies can bend light that passes by them, causing distant objects to appear distorted or even multiple times. But sometimes we see this light bending where there's no visible mass. Last but not least, we've got the cosmic microwave background, or CMB. This is the afterglow of the Big Bang, a kind of cosmic baby picture. Tiny fluctuations in the CMB give us a snapshot of how matter was distributed in the early universe. And guess what? The patterns we see match up with the idea that a large amount of unseen, or dark matter, was already pulling things together even back then. The evidence is compelling, but what does this mean for our understanding of the universe? Well, it suggests that we're missing a major piece of the cosmic puzzle. And if we want to truly understand the universe, we'll need to shine a light on dark matter. Dark matter might be invisible, but it plays a massive role in shaping our universe. Let's delve deeper into this unseen cosmic influencer. You see, dark matter isn't just hanging out in the universe doing nothing. It's a major player in the formation and structure of galaxies, including our very own Milky Way. These galaxies are like cosmic whirlpools, spinning and churning through the cosmos. But without the gravitational pull of dark matter, these galaxies wouldn't hold together. Think about it like this. Imagine you're trying to build a sandcastle, but the sand keeps slipping through your fingers. You need something to bind it together, right? That's where dark matter comes in. It's the unseen glue that binds galaxies together, keeping the stars, gas, and dust from simply scattering into the void. But its influence isn't limited to just galaxies. The Big Bang Theory, which explains the creation of the universe, heavily relies on the existence of dark matter. After the Big Bang, the universe started to expand. This expansion wasn't uniform, though. Some areas had more matter, leading to denser regions that eventually became galaxies and clusters of galaxies. It's believed that dark matter was integral to this process, providing the gravitational scaffolding upon which ordinary matter could gather and form the structures we see today. Without dark matter, the universe as we know it wouldn't exist. The cosmic web of galaxies and galaxy clusters would be a mere fantasy. The stars that light up our night sky might not have had a chance to shine. And our own existence, well, that's a whole other story. Dark matter, despite its name, isn't dark or evil. It's a silent, unseen hero of the cosmos, shaping the universe and making life as we know it possible. It's the missing piece of the cosmic puzzle that scientists are still trying to fully understand. So next time you gaze up at the sky, remember, there's more out there than meets the eye. Dark matter, an unseen force shaping our universe. Isn't that a mind-bending thought? We've delved deep into the enigma that is this invisible matter, a silent player, with a major role in the cosmic drama. It's the glue holding galaxies together, the unseen hand sculpting the cosmic web. We've glimpsed at the evidence, the gravitational lensing, the cosmic microwave background radiation, the way stars orbit within galaxies, all hinting at something more, something we can't see. It's a cosmic mystery that continues to elude us, a riddle waiting to be solved. But we're not discouraged. Oh no, we're emboldened. The chase is on. Scientists across the globe are probing, testing, theorizing, all in the pursuit of understanding this elusive dark matter. We may not see it, but dark matter reminds us that there's always more to discover. Because in the vastness of the universe, the unseen may be the most fascinating of all.